Hello there and welcome to this Pandas challenge. That's day 10. In this challenge, we're going to be going through a set of Pandas library concepts that will be important in data analysis, manipulation, as well as exploration. So let's get started. The first thing that you need to do is to visit the practice resource link in the description section. So click on that link. It should take you to this page, a page that looks like this. Once you get here, you need to click on the sample practice resource link, and that should take you to this notebook. And when you get to this notebook, you need to first of all save a copy of this notebook. So go to File, then Save a Copy in Drive, and then it should open in a new tab, and you should close the original one and work on now that new one. For my case, I'm just going to be using the practice notebook and now open it in playground mode. If you want access to the practice notebook, feel free to explore the option of becoming an afterwork member. That should provide you with the opportunity to practice a whole lot more, because the practice notebook has extensive challenges while the sample just has a few challenges. Also, something to note is that you can always pause the video, then rewind the video if you need to. If you feel like I'm too fast at some point. So getting started, we'll start by running this particular cell. So under prerequisites, you need to run the first cell that says import the Pandas library, which just means we're going to import the Pandas library that we're going to be using for this case. All right, the first concept that we are going to be learning is about how to determine the size of a data set. How many records are there in the data set that we are working with? So assuming that this is a data set that's located in this URL, so this is how the data set looks like. If we wanted to determine the shape or the size, which normally it's how many records, we would use the shape property from Pandas. So we would reference the df data frame, then apply the shape property to the data frame, and that should give us a tuple. So if I decide to just run this, what will be printed out will be it's a data structure in Python called a tuple. The first is the number of records, the first element in that tuple or tuple, however you call it, and the second one will represent the number of columns. But to access now the number of records, we usually use, let me just go back, shape, then square brackets, then the first position, the position of that first element in that tuple, and for the second element in that tuple we use the index 1, or position 1. So in this case we'll get the number of rows, which will be the result of this, and the number of column, which will be the result of what's here. And then here we're just printing out the number of rows as well as the number of columns, with also this text included. All right, pause the video and then work on the challenge. Sometimes you might want to select top records. So instead of using the, not select top, multiple records, it's just selecting an individual record. So instead of just using maybe another method like the lock method or the ilock method, we can decide to use the take function that helps us to get the records that we want. So for example, if we want to get records 1, 2, 3, 4, we would use the take function, and we apply it to the df data frame. So let me load this data frame. So assuming I wanted to get the record that appears at record 4, maybe 4, or index at index 4. So we pass our index as an element in a list. So at index 4, I will get the record that actually has this index 4. So I apply the function, and then I use square brackets, and then specify the record that I want, the index record. So the index of this record, which is index 4, is index 4, and that's what I specify, and that's what I get here. If I wanted maybe to get a multiple of them, I could say 2, 3, 4. That would give me the 3 records that I have. So the ones that have index 2, 3, and 4. So you can select any records, any sort of records that you might want using the take function. All right, pause the video and then work on the challenge. Sometimes you might want to rearrange how columns appear using the reindex method. So instead of just referencing the column names, you might want to just reorder them originally in the data set that we had. maybe it's because we might want to have some better visibility of some of the data or that we have. Maybe we want some columns appearing first. So let's load this data set, and to rearrange those records, we need to use the reindex function, and we pass to it we set the parameter columns to be a new order value or a list that contains the specific column order that we want. So we would need to rename, or we would need to define the order of the columns that we want. So we want employee ID, then last name, then first name, then then job title, then department, etc. So we will need to do that using the reindex method, and we pass that to the columns parameter in that function, and then we save that in DF, and then we preview our outcome. So our outcome, as you can see, we have employee ID, last name, first name, job title, department, etc. Pause the video and then work on the challenge. We can also rearrange columns using the insert method. So instead of using this approach that we've used here, we can decide to use what is called the insert method. So initially, when we have this data set, we would see that we have these columns. These are the columns that we have at the very top. So to, first of all, assuming that we wanted to move location to maybe a particular position, maybe that position would need to have a number. So this is the first this is position 0, this is position 1, 2, 3, then 4. Assuming we wanted to have location, so location it at position 4, because a position here would start from 0, 1, 2, 3, then 4, then job title would be 5. Then we can first of all decide to remove the location column or the column of interest. So in our case, we use the pop function or pop method for that, specifying the column that we want to remove. And we actually save it. We save it in a variable, and then we use the insert method. And this allows us to, first of all, specify the position where we want our column to appear, then the column name that we want, and then we now pass to it the column that we removed from the location, from the data frame itself. So here, so location will be stored, would now appear at position 4 with this location name, and then we display the outcome, and we should be able to see that we have now location at index 4. So 1, 2, 0, we start with 0, 1, 2, 3, 4 at position 4. All right, pause the video and then work on the challenge. Sometimes when we have some data set, we might want to handle missing values if they're missing values, because that would ensure that our analysis is reliable. So assuming that we loaded this data set, we are displaying 10 records in this case to just get better visibility. So we can see in salary column, there's a missing value, so NAN. There are many techniques that we can use, but in some cases where we assume that the previous value, assuming that this is this previous value before the missing value, is actually much more closer to what is realistically missing, we can use an approach in Pandas that allows us to use this last approach. And that's what we will, that process of using the previous approach to fill in, to fill in the missing value is what we are calling forward filling. So we take what is here and we fill that in the next value. If we wanted to use the previous value, we would call that backward filling, and we would use another approach, not so much different from what we have. So in our case, this is this is the code that we use to check for missing values. So we can see in this data set we have 36 missing values in the salary column, and joining it we have 34. So assuming that we wanted to just do that bit of handling missing values using the forward filling approach, so we would use fill NA. So we specify the column that we want to fill in, then apply the fill NA function. Then inside we specify the value of the method that we want to use. We want to use forward fill, which is what we specify here. and then we set in place as true. So here, what is going to happen is that we are going to be storing, you're going to be applying forward filling approach to now this particular column, then we display the data set afterwards. All right, so yeah, so if you look closely in our previous data set, the record with index 4 had the missing value. And when you look over here, the record with missing with the index 4 has now the 90,000, which was not there, and it's actually carried from here. If we had wanted to do backward filling, so like doing backward filling, what we would have done is to use B fill instead of F fill. So you'll note that here I have, this is the missing value, so we'll use now 70,000 in this case. So assuming, let me reload this data set so that we work again with that. This is just for showcasing backward fill. So you should see at index 4 we have 70,000. And then we can display how many missing values that we have. So in this case, you'll note that we have that in the salary column, we have 35, but initially we had 36. Now there's still 35 more remaining. So one might ask why and the other values not filled in. The reason is because of this. So if I am to decide, if I am to print out, let's say DF, then the tail and the last maybe 50 records, you'll get to see that we have missing values for values from number 40. So it means that we cannot be able to fill in the missing values. Say, for example, if we wanted to fill in, let's say, NAN, we are actually using the previous NAN, the same case with NAN for here. So, but this should actually be filled in using this particular value, value if we use forward fill. So the reason why we have NANs is because, again, we have missing values for those values that we want to use. All right, pause the video and then work on the challenge. In some cases, when we are preparing data to use for training of a machine learning model, we would need to have data that doesn't have textual data, like as you know, like you have when you have data like what you have here. You may not use the data here. You need to convert it into numerical representation. So we would need to replace those textual values with the equivalent numerical representation. So there are different techniques. These techniques that we use to perform that process of finding a numerical representation and filling that in our original data set is that process. It's called encoding, and there are many encoding techniques that we can get to learn. There's this one that's called ordinal encoding, ordinal encoding technique that involves converting, say, categorical variables which would contain textual data. We would convert them with the categorical variables into numerical variables or numerical representations. But this approach would retain the order or rank of categories. So for example, we might have, let's say, this data set that looks like this. Assuming that we wanted to perform, I'm trying to look at, assuming that we had location. This is just an example, just note this, but it's not the best example. A better example would be, let's say, something like temperature, assuming that temperature was a categorical variable, and we had three values, low, medium, and high. So the order of those, we could decide to replace, let's say, low with 0, one with, no, not low, medium with 1, then high with 2. So and that would still carry some meaning. Like the lower value would mean that there's meaning that we still carry on with regards to that. So ordinal encoding, how we're able to apply that technique, we import the ordinal encoder class from the pre-processing module from sklearn. Then we create an object of our ordinal encoder. We specify then the categorical columns that we want to encode using the ordinal encoder, and then we use the encoder object and we refer to its method, that's fit transform method, and we pass to it the columns that we want to apply ordinal encoding, and we store the output inside what we have here, and we display now the data that we need. So our final data here will have numerical representations having taken into consideration that there's some sort of order that is evident within those particular, or is present within those categorical variables that we are working with. All right, pause the video and then work on the challenge. In some cases, we might want to calculate maybe some sort of percentage change. So if you're working maybe with time series data, for example, if we have this data set that contains time components, so we have a date column over here, temperature 1, temperature 2, etc. Assuming that we wanted to calculate maybe the percentage change from this record to this other record for temperature values, then what we would do is here we are just going to create a new column that will contain those percentage values. So we would reference the column that we are interested in, so to calculate percentage change. So we say PCT change, we apply percentage change on that column, then we multiply by 100 so that we have a percentage instead of a decimal. So that's, once we've done that, we just display the updated data frame because we've created this, but this new column, and that's what we get here. So the first one doesn't have any percentage change because there is no previous value, but the rest do have. Pause the video and then work on the challenge. In some cases where, again, we are working with time series data, we might want to resample the data from maybe daily frequency to monthly frequency to just be able to answer some research questions. So for example, here within this data set that we have, we might have, so this is again not the best example, but it could work for just learning purposes. You might need to work with maybe something like what we have here. So assuming that this is a date that we have and it's of interest, and we want to resample to maybe months, we would reference generally this column. We would need to convert it into a date time format. Then we set the index for set that column as the index of the data frame. Then we use the resample function on the column that we have an interested in. Maybe wanted to group or have some sort of salary, not group, but have some sort of salary, but resampled in terms of months. So we would apply resample function to the variable of interest, that summary. Then we apply sum function to get the total for that particular month, and we can just apply reset index to have a data frame, Pandas data frame output. So we can see here that we have 2019 August, this was the sum salary. 2019 September, this was the total salary. So it went up, then it went down, then it went really up, then it went down, then it went up, then slightly down, yeah, etc. But I think you get the idea here. All right, pause the video and then work on the challenge. All right, the other challenge that we're going to be learning is called one-hot encoding. It is it's one of the many challenges, one of the many encoding techniques like the ordinal encoder. For this particular case, we would normally just convert categorical variables to a numerical variable, but this essentially what it does is uses a different approach. It creates what are called dummy variables that contain true or false values. I think we've actually covered this in the past, so it should be something that should be second nature to work towards. So in our case for season, so season is what we want. So we would essentially have seasons. There are usually 4 seasons. So we would have 4 new columns because the season column has 4 different unique items. That's summer, spring, autumn, and winter. And the values for each and every of those columns will be the true or false, depending on whether the record has the actual value that is specified. So yeah, so let's apply get dummies function to our data set, the specific column that we want. So we have 4 new columns: season autumn, season summer, and season winter. All right, pause the video and then work on the challenge. Lastly, we can also create a scatter plot quickly if we want to. I haven't included some text here, but I'll update it. We can have a scatter plot to be able to determine the relationship between two variables. If B is a positive linear relationship or negative, then we can use a scatter plot for that. And how we do that is we usually would first of all need to identify the two variables that we want to work with, and you know, or the ones that we want to find whether they have relationships. So we could decide to work with temperature and humidity and try to understand if temperature increases, does humidity increase, in this case, on the environment that we have or in the experiment. So that's what we do. So we use the DF data frame, and we apply to it a plot function, which takes in several which we would define several parameters for. The first one would be kind parameter, which would take the value scatter, which just ensures that we create a scatter plot. Then we define what we want on the x-axis, what variable we want on y-axis, and also the title. And then, yeah, so that's it basically. Here we're not using any other library, just using Pandas. And we can see that as temperature decreases, humidity increases. No, as humidity decreases, temperature increases. All right, pause the video and then work on the challenge. Okay, so that's it. So that's it with regards to this challenge. I hope you found it helpful, meaningful, and you are getting some value from these challenges. If you'd want to be informed when we post such future videos or course challenges, be sure to subscribe. And if you'd want to be if you do want to tell us that we're doing a good job, and it also helps others to know that this is a good tutorial, a good challenge, be sure to give this video a thumbs up, and all the best in your learning journey. Bye-bye.